Hello, I'm George Malin, the Managing Editor of IoT Now, and welcome to the webinar. The topic is how observability is helping teams develop and deploy better connected devices. For a long time now, we've seen devices of all types become more complex, and embedded devices in particular increasingly need to incorporate greater processing power, enhanced memory, the latest connectivity technologies, and the ability to integrate into wider edge intelligence strategies. Add the inevitable mention of AI to the mix, and it's clear to see that the simple sensors or on-off devices of early IoT are being replaced by connected devices that feature far greater technical complexity than ever before. The added pressure on engineers doesn't stop there, though. Embedded devices are required to be developed faster and faster. Companies increasingly recognize that time to market is a competitive differentiator, and arriving late can result in project failure. Development timelines are therefore shrinking, even as devices become more complex, putting even greater pressure on engineering teams in a pincer-like movement. In the traditional technology world, engineers have sought to streamline development by ensuring they have the observability into products to enable them to be rapidly fixed and debugged in the field. But for embedded devices, which are power constrained, have limited compute resources, and are deployed at massive scale, traditional observability solutions simply aren't practical. Even so, embedded device engineers need visibility into their products so they can address issues before customers are impacted by them. I'm therefore delighted to welcome today's speaker, Francois Baldassari, the CEO and co-founder of Memfold, who is going to explain how embedded device engineers can ensure observability by adopting approaches that have been specifically built for embedded devices. I should point out that Francois is going to stay on after his presentation to take the questions that we have received. And I'm sure that will be an interesting discussion. Now, without further ado, let's hand over to Francois. Francois, the floor is yours.
Thank you, George. And I'm so glad to be here today with you and the IoT Now community. As you mentioned, my name is Francois Baldassari, and I lead the Memfold team and the cloud organization more broadly within Nordic Semiconductors. Today, I'm very excited to talk to you about observability because I think it is such a crucial practice that more and more teams are adopting. And I believe that it is, something that many of your listeners and readers are interested in and want to figure out how to use in their next products and on their roadmap. But before we talk about observability, let's talk a little bit about building connected devices. Let's talk about the why. As you've mentioned, building connected devices is just getting harder. 10 years ago, 20 years ago, devices were very simple. You oftentimes had an 8-bit microcontroller you wrote with a few kilobytes of RAM. The software was simple, and most of the complexity was in getting the thing designed and manufactured. Today, software has started to dominate the complexity of getting a device to market, and with it comes new challenge. Talking to leaders in the IoT industry, we hear again and again how big of a challenge software has become. Some of them report over 60% of the costs of bringing a device to market to be software. And this continues to escalate with many projects exceeding 100,000 lines of code, and that number continuing to grow. If you look to the automotive industry or some of these big complex machines, we've passed 10 million lines of code on some of these devices. It's a lot of software, and building it so that it is reliable is becoming more and more difficult. Competition, though, is relentless. And so, although the complexity has increased, the timeline, if anything, have shrunk. The average IoT project and product is developed within just 16 months. That's 16 months to do the mechanical design, the electrical design, the layout, manufacturing, tests, and of course, all of this software. So we have increasing costs, increasing complexity, increasing amounts of software with a decreasing product development timeline. And if you look at what they're doing in Asia Pacific, they're shrinking those development timelines even further, where we see some Chinese companies or Taiwanese companies develop products as fast as within 6 months. However, because these are physical products that live in the world, they have to work for a very long time. On average, about 8 years. That's how long on average an IoT device stays out there in the world. And in those 8 years, a lot will change. New Wi-Fi standards will emerge, the RF environment will change, the devices might be taken into new contexts or new environments. New versions of mobile operating systems will ship, new Wi-Fi routers, new Bluetooth endpoints, and so on and so forth. And so all of this change will mean that the performance of the device will change as the environment changes. And figuring out how you can stay ahead of this is critical to keeping these devices out there in the field, performing as expected. However, when you square the length of time, the speed at which the environment changes, and the complexity of the devices themselves, it becomes pretty quickly apparent that we have a visibility gap. You would imagine that faced with lots of complexity, a changing environment, and a long lifespan, teams would have long invested in ways they can monitor the performance of the device so they can quickly get ahead of problems. But today we find many organizations with no visibility. In fact, many of the organizations will tell us that customer complaints is how they know whether things are working or not. Whether that's a big customer calling you or a thread on Reddit going viral, that is a poor measure for quality and performance. The overwhelming majority of organizations do not even know how often their devices crash. And let me tell you, if you don't know how often your device crashes, it probably crashes more often than you'd like. And so what's the end result of that? Well, as complexity increases, without new tooling, without new monitoring, our engineering teams are becoming more and more overwhelmed. Half of those teams take more than a week to identify a defect when it occurs in the field. About half of them take another additional week or several to deploy a fix to this issue. And the average engineer reports spending 3 months per year debugging issues. That's 25% of their time. As you can imagine, this has a real cost, but it's not all. The lack of visibility also leads to higher recalls than we'd like, with 38% of respondents in our surveys mentioning that they'd had to recall or update a product in the last year due to a defect. More than half of them having had to delay a launch in the last few years due to last-minute defects. And most of them, the overwhelming majority of them, reporting that the lack of visibility is tying up their resources and getting in the way of growth, investment, and innovation. So I hope you're leaving the first part of this webinar convinced or understanding that there is an issue here. Complexity is increasing, visibility has not kept up, and we're spending a lot of money, a lot of time, and getting a lot of headache, frankly, as a result of it. All right, so what do we do about this? As you can imagine, I've been thinking about this long and hard over the past 7 years, and have started building different parts to the answer. And as we wrestle with more and more software problem, it is natural that we look to the software industry for inspiration. Now, I'm not suggesting that we throw the baby out with the bathwater and turn into software companies. But I think there is something that has been figured out in the software industry about software quality. If you go to google.com or one of those websites, it always works. It's always there. So what have they learned about software quality? How do they manage to ship software regularly at scale without major defects? And how may we apply it in a hardware-specific, thoughtful way to the products we're developing as IoT innovators? And the answer, so we did this analysis and we came up with a pretty clear answer. In the software industry, they have developed a set of best practices and they're actually quite mature. Every software organization uses them. And those best practices are anchored around a capability that is called observability. Observability is very simple. It is the ability to collect data and telemetry from devices, or in this case, from software, as it operates, to get a data driven empirical view of performance and reliability. On most websites, what you will find is that a tool such as Datadog or New Relic is used to automatically instrument the website and provide some nice dashboards for the production engineering teams who are responsible for its reliability. This has spawned a big industry, and it is in fact a category that Gartner, the big analyst firm, tracks. We believe that employing the same strategies on the hardware side will yield similar results and help us achieve reliability at lower costs. But of course, the solutions we talk about are not built for embedded devices. They consume a ton of power. They do not cope well with intermittent connectivity. They might consume way too much bandwidth and oftentimes require gigabytes of storage, which is of course not appropriate for something like a nRF52 running Zephyr, right? And so although observability can help find and fix issues in deployments before customers are impacted, it has to be adapted to be appropriate for these kinds of devices. And a solution that balances bandwidth, power, compute, and the amounts of data, the insights that it can give is critical. But if we're successful in doing that, we will see a huge change in how our embedded development teams work. Today, we're moving too slow. We are dependent on extensive QA testing in order to make sure that we're as good as possible out of the gates. And then we only find out about problems when they become big enough that customers start complaining en masse. As a result, we become afraid of making changes in the field because we're not sure whether we will make it better or worse. In this new world, with observability, we can ship fast and iterate with real-world data. We can identify issues before customers start complaining, and we can push updates much more regularly because we're confident that if a problem occurs, we will find out about it very quickly. That's the theory, but let's look at the practice. What do we see in practice? So at Memfault, we've had the chance of working with some incredible organizations and deploying observability on their engineering teams and in their broader company processes. And what we found is remarkable. For example, no pun intended, our customer Remarkable, which makes e-readers and note-taking tablets, has found that they have been able to triple the rate at which they release firmware. Because once they became confident in their ability to quickly identify problems, their velocity increased, their engineers could spend more time on innovation, and they had less fear that they might ship a bad update. Our customer Ultrahuman, a maker of connected rings, has seen a 10x decrease in RMAs. 10x, you read that right. That is a massive change to their business. How did they do this? They used observability to identify the top problems driving returns, and they solved those problems. It sounds simple, but it requires the right data. Our customer Gab saw a massive improvement in their business. Not only did they decrease support costs by resolving the top issues proactively, so driving down support volume significantly, but they also saw a massive increase of almost 2 stars in their Amazon reviews. These kinds of impacts are within your reach. It is a matter of employing the right tools and the right processes for the challenge at hand. And this is what the Memfault platform is here to do. At Memfault, we've taken our experience building observability systems in-house at some of the world's leading brands and built a platform which you can use today on your devices. It pairs an OTA update engine, which you can use to roll out updates in a controlled way, with a first in the market observability platform, which lets you automatically collect data from your devices, identify issues, debug crashes, and understand the performance of the devices. The Memfault platform works in a very simple way. First, it comes with an SDK. That SDK gets baked into your firmware. It is not particularly large. It's about 4.5 kilobytes of code space and requires about 1.5 kilobytes of RAM. That SDK integrates with your firmware and works across all kinds of operating systems and even on bare metal devices. The Memfault SDK will collect data as your device operates. Very little data, but every hour a few data points. And when connectivity is available, it will upload that data to the cloud. It can do so directly if it is IP connected via a Wi-Fi or cellular connection, but also works just as well with a gateway, whether that is an iOS device, a mobile phone talking to your device over BLE, or whether that's a Windows PC talking to your device over USB, or anything in between. On the cloud side, we take the data we receive from the device and we augment it and analyze it to give you a complete picture of the health of the device. Here's a few types of analysis that we do that you may find interesting. First, we will aggregate the data across your entire fleet and give you some complex aggregates that we pre-compute for you so that you can get answers very quickly. So if you're trying to figure out what is the average battery life for my device on my latest firmware in the field, and how does this compare to the previous version, the answer is just a few clicks away. Or if you want to know how often do my cellular connected devices try to reach the network and fail to establish a connection with the cell towers, and which networks are particularly impacted by these problems, that answer is just a few clicks away. A second thing we do is we aggregate and deduplicate issues. So when a device experiences a crash, we ingest that crash, we analyze it, and then we compare it to all the other crash we've ever received. That means that instead of looking at each individual crash report one at a time, Memfault will merge all of them into one, all the ones that match, so that you only look at one report for potentially tens of thousands of instances. This saves a huge amount of time and helps your team get to the bottom of prioritize the most important problems and get to the bottom of them. So these are just a few of the analyses we do to make your life easier and give you real, it's not just about collecting data, it's about getting insights from the data. It's about getting leverage from the data. Many organizations are drowning in data, but getting to the right answer, getting to the insights contained within the data, the signal from the noise, that's a big part of what our cloud platform provides. As I mentioned, Memfault is built for embedded devices. It works across all major embedded platforms, whether you're on a microcontroller writing bare metal codes or using FreeRTOS, Zephyr, or ThreadX, whether you're running an Android device that is running a AOSP release from a few years ago, or you may be building an embedded Linux, a Yocto device, a Buildroot device, or Ubuntu device. All of it is supported by the Memfault platform and our range of SDKs, which are optimized for all these different use cases. It is all available on GitHub. You can get started with a few clicks. The Memfault platform works on low power devices. It consumes very little battery, just a few data points collected and uploaded per hour means that it is in the noise floor of your battery consumption. It works with any connectivity setup, whether you're connected over BLE, LTE, Wi-Fi, or other solutions. And it works on highly constrained devices. It is compute optimized. So we've seen Memfault work really well on even very constrained microcontrollers. Though I will note that today we only support 32-bit platforms. So if you are at Mega 328 today, we cannot quite scale down to that size. I often get asked, when in my program, this is a new concept for me, when in my program should I integrate observability? And so we typically see two different moments where teams integrate observability into their process. The first is at around the EVT milestone, when you start having a good number of prototypes in-house, let's say 100 prototypes or more, and are doing some internal testing. You have a few employees with devices, you may have some close partners with devices. That's a great time to introduce observability because there's typically a lot of problems with the devices during that stage. Another good time to introduce observability is in the PVT stage, as you're starting to plan your launch and think about your production ramp. Because that's the moment where you're going to be really looking at getting all your ducks in a row for launch. At launch, you will want to have that visibility because launch is the critical moment where your products makes it or not, right? A major issue might have slipped through QA, and your ability to quickly find and fix it could be the difference between seeing a huge spike in return and terrible reviews or being praised for your quick response. And of course, if you didn't get observability in place before launch, it is something you can do after launch. We see teams come to us and asking for help with observability who've had a product in the field for a few months with problems that they have not been able to fix. And so at that point, adopting observability allows them to, it is done as an OT update. They take, in the case of Memfault, they take our SDK or whichever solution they choose, integrate it into their firmware, push an update, and start receiving data. This is a good bit of work at that point. But once the data arrives, we see that reliably customers and companies are able to resolve problems that they face. So it's never too late to adopt observability, although we do recommend you make it part of your process during development and before launch. Great teams have started using observability. They use Memfault, they build solutions in-house. They certainly aren't just waiting for the customers to complain. And so we're lucky today to work with some amazing brands across a wide range of verticals and industries, from industrial to ag tech to health to consumer electronics. And they say wonderful things about us. I love this quote from Nico at Remarkable, who said, "We're both their insurance policy and their velocity engine." That is what you can achieve with observability. And of course, you can go on our website, memfault.com, to see more testimonials and case studies. I encourage you to go do that and see the results that other teams have achieved. And of course, to get in touch with us if you have any additional questions or want to learn more about observability. And with that, I hope that this gave you a good overview of what observability can be or should be, and why you should consider it for your next program so that you can move fast without breaking things. I'm always happy to hear from you and talk observability with you. It is one of my favorite topics. And in the meantime, I'm turning it over to George to talk about some of the questions we've received.
Fantastic, Francois. Thank you. That was a great presentation. I guess first up, the big news for Memfault was the acquisition by Nordic Semiconductor, which completed back in July. So the question we've had in regarding that is, does this mean that Memfault is now only for Nordic-based devices?
Thank you for asking the question, George, and whoever submitted it, because this is one that we have been getting a lot. Memfault continues to be a cross-platform solution, and there are no plans to change that. We want to bring observability to every device maker because we think this is so important to get right, and we think everyone stands to benefit from it. So this is not Nordic specific. We're very lucky to have the backing and support of Nordic, a really great organization that gets software and understand how to build devices. But we're continuing to support the devices as you build them, whichever technology choices you make.
Okay, great. I think that's answered that question really well. Moving on, how does Memfault collect diagnostic data from devices without impacting performance or battery life? I think you touched on it a bit during the presentation.
Yeah,
but,
very often when I talk to engineers, their first instinct is, oh, we're building a power constrained device that's only connected once per day over satellites. We can't possibly do this. And I'm here to tell you that you can. In fact, observability does not require huge amounts of bandwidth or power. And I'll share the insight with you. I think you'll get it immediately, which is that with millions of devices, or even thousands of devices, if you collect a data point every hour, one data point, right? You collect the battery level once per hour from your devices. Well, a few hours of runtime and you'll have thousands or millions of battery data points. And so you'll get a really, really good picture of the performance of your fleet. But each device has just sent a 32 bits number once per hour. That's negligible in terms of performance, right? You're just taking a number and writing it to a new area of RAM. That's a couple instructions, and then you're doing you're tacking on a little bit more data on one of your data transfers. So we find that for the vast majority of our customers, they see no measurable impact on their battery life or real-time performance from implementing observability. And so what we typically say in terms of constraints is we like to see devices who can at least send a few hundred bytes per day. That's certainly a constraint. If you're sending 100 bytes per week, it's going to be really tough to do observability, but that's really rare. Most devices send more data than that. And number two is it's good to have a peak bandwidth in the 1 kilobit per second range, so that when you do send that message, it can happen fast.
Okay, next we've got a kind of overlapping question, but the emphasis is different. The question is, can Memfault work on devices with intermittent or limited connectivity, and how does it handle data buffering or retries?
Yeah. Yep. Great. Very common question we receive as well. Thank you for asking it. So we work and we are used to building observability for devices that are not always connected and certainly are not IP connected. And so, for example, a fitness tracker connected over BLE, which is a device, I've built devices like that in my career, may only be connected when the user is near their phone. And so if you want to understand performance during the time when it isn't connected, you have to store the data on device. So the way we do this is we provide adapters to save data to RAM or to flash. If you save it in RAM, it needs to be what's called a no-init section of RAM. That's going into the technical nitty-gritty, but what that means is that is RAM that is not erased on reboots. Because most IoT devices actually maintain their RAM states across the hardware retains the RAM state, and it is the bootloader that will erase the data on reboots. And so if you work and make sure your bootloader avoids erasing that part of the data, you can store data there. Of course, it is even better if you can store data in flash, typically because we have more flash and it's a little bit less complex than setting up a no-init section of RAM. But our SDK will manage that memory. So you tell us, here's some memory, you can buffer data there, and we'll take care of buffering the data and then extracting it. And any observability system you end up selecting or building will need some similar functionality. If anything, because understanding why a device might not be connected is important. And so collecting data when the device is not connected will be critical to debugging connectivity itself.
Excellent. So moving on, the next question is, what does integration look like for existing firmware projects? Is it an SDK drop-in, or does it require OS or RTOS support?
So the integration will depend a little bit on your device. We have turnkey integrations for a range of platform where you just drop the SDK, recompile the firmware, enable some config flags, and are off to the races. But on some other devices where you might have a custom flash driver, or you may be using your own real-time operating system that you developed in-house, you will need to do a little bit of work to integrate these pieces together. We estimate that on the high end, for the most complex integrations, it may take an engineer about 2 weeks to get up and running with observability. But in the happy path, if you're running on a Linux device, for example, or you're building on a Zephyr device, you can be up and running within a few minutes of downloading our SDK.
So how does Memfault handle different process architectures and real-time operating system environments?
Well, we handle it by working really hard. We have spent years, right? I started building Memfault in 2018. We have spent years building SDK configuration and hooks for a huge variety of devices. There is no shortcut, right? At the end of the day, there is great diversity in the IoT industry, and we had to do the work to support it all. One of the advantages that we had is that most devices nowadays use ARM architectures. They're using Cortex-M or Cortex-A processors. There's a few, I know, for example, Espressif makes some RISC-V based devices or Extensa based devices, but the majority of the industry is solidly on ARM. And that means that there's a consistent diagnostics interface on those devices, right? ARM has a standard called CoreSight. You may never have heard that term, but it is a standard set of diagnostics interfaces that are available on all ARM CPUs and MCUs. So that does make our life easier. We didn't have to integrate with as much diversity there. And we've really become experts in how to do that.
Okay, moving on. The next question we've had in is, what kind of metrics or events can Memfault track out of the box, and how customizable are they?
So out of the box, we'll give you the data points that we think every device should care about. We'll give you the stability of your device, how often it resets, for example, how often it experiences problems. We'll give you how often it is able to successfully connect. So in any given hour, what percentage of the time was it successfully talking to your cloud or your backend over its wireless connectivity or whatever connectivity link you have? We'll give you statistics around flashware. We see that many IoT device makers care a lot about flashware. So what's the health of your flash? And we'll give you statistics around battery life if your device is battery powered. All of that will be out of the box. On some platforms, we're even able to automatically give you network statistics, things like Bluetooth connection intervals or the connection parameters of your LTE connection, for example, on a LTE device. But the really powerful piece of our observability platform is how extensible it is. We give you APIs in our SDK that let you add your own metrics with just 2 lines of code. So let's say, for example, that you're making a camera-based device and you want to track, the recording modes that are being used, right? Whether they're doing slow motion capture versus taking pictures versus taking video versus doing black and white versus color. And you want to track the sensor temperature that is recorded on the device, because your CMOS sensor might get quite hot if you do slow motion video, for example, you would create two new metrics. One of them would be recording mode. The other one would be temperature. And with just 2 lines of code each, so 4 lines of code total, recompile your firmware, flash it, run it, you'd start seeing those data points flowing in the Memfold platform with no additional work needed, no SQL queries to write, no gateway changes to make. It all happens transparently from the firmware to the cloud.
Excellent, thanks. So moving into kind of use cases for Memfold, the first question in this kind of category we've had is, how does Memfold help teams decide when it's safe to roll out a firmware update to a wider portion of their fleet?
Yeah, measuring things helps you establish success criteria and KPIs. So every organization will have different thresholds of quality that they want to meet in order to more broadly distribute their firmware. We always recommend organizations do two things. First is they specify upfront what the quality bar is that they want to hit. So for example, you might want your device to crash no more than once per month, right? So that might be part of your quality criteria. And so you'd write that down. And you might want the battery life of your device to be 8 days, let's say. So you can implement those in your observability platform in Memfold. You can create a dashboard that shows you each of those dimensions, and you can look at how they change from firmware version to firmware version. So that's the first step, is you write it down and you give yourself some goals. The next step is to do a stage rollout. Using our OTA platform, you can do a limited deployment. Start with 5% of the fleet. And then you measure and compare. Are you doing better or are you doing worse than your previous version? And if you're doing worse, are you still meeting your goal or are you now below your goal? And I think at that point, you can make a call. If you're below goal, you probably don't want to continue the rollout. You need to get to the bottom of it. If you've regressed slightly, perhaps it's fine to continue. And so then you'd go to 20% of the fleet and you'd see other numbers still looking good. 60%, 100%. What's amazing about this approach is that if there is a problem, number one, it only impacts the small percentage of your fleet you've rolled out to. So you've limited the blast radius. Number two is you find out about the problem right away. And so you can quickly fix it. And by the time you've rolled out to your entire fleet, you know your metrics are looking good.
Sure, that makes really good sense. Next question is, can Memfold integrate with our existing tools, for example, our CI/CD pipelines, our issue trackers, or our cloud dashboards?
Not only it can, but really you should integrate your observability tools with all those things. For example, your CI/CD platform. The best teams out there nowadays use CI and CD, that stands for continuous integration and continuous deployment. They use these kinds of platforms to automatically build and release their software. The key here is that we want reliable builds. We want to make sure that if I compile, if I release the same version to two different sets of devices, they get the exact same firmware with no surprises. So you want, if you're using something like Memfold to do OTA and to do your metrics, you want to make sure that your CI pipeline is pushing your binaries and your firmwares straight to your observability platform so that they are matched. Similarly, you'll want to integrate into some of your other data tools, right? Build dashboards that integrate data from your observability platform and data from your support team or your billing systems. And that all is supported via our API. And of course, if you have a ticket system like Jira, you want to be able to go straight from observability to clicking a couple buttons and opening a ticket so that your engineers can start fixing the problem. So all of this, I think, are core features of an observability platform. There are things that, of course, we support out of the box with Memfold, and that you should look to as you think about your observability strategy.
Okay, I think I know the answer to this question, but I'll run it by you anyway. It says, for teams already collecting logs or metrics manually, what's the incremental value of adopting Memfold?
So we often hear, I already have something. I'm already doing something. Why should I use a fancy cloud observability platform? And of course, it is for you to decide for yourself. But here are the things that I see. Number one is building these systems and maintaining them as your fleet scales, as new devices get shipped, is non-trivial. It is real work. It is specialized work, which frankly is undifferentiated for you, right? Like the two IoT organizations will have the same needs from an observability perspective. And so building it twice is such a huge expense of resources when putting resources together and relying on a shared solution can be so much more efficient. So first about efficiency, right? It's about using your engineers for what differentiates you, from what's unique about your company and your products, and not to build common infrastructure. And this is real. Like in our conversations with Remarkable, for example, if you read the case study, you'll see that they were able to free up about 10 engineers to go to move away from working on standard infrastructure and to focus them on building innovation and things that are unique to Remarkable. That's number one. Number two is the capability, the ability to automatically process and deduplicate the data is a huge time saver. Because we see many organizations that what they do is they allow customers to submit logs from their device. So you get one-off logs intermittently. But then those logs all end up in a big database somewhere, and looking through them is really difficult. Certainly getting any kind of trends from them is impossible because they're just one-off and there is no additional analysis. Using a commercial observability solution, you get the ability to see to have the data automatically analyzed and see the top problems brought up to you using the software and AI instead of having to trudge through all the data yourself.
Okay, let's wrap up with a final question. It's in a similar vein to the previous one. The question is, how do teams measure success after implementing Memfold, and what KPIs and outcomes improve the most in a typical deployment?
So in any project like this, deploying observability, it's of course important that you define your own success criteria, because they will change a little bit from organization to organization. But here are the ones that we see most commonly. Number one is seeing a decrease in the number of defects. And so you may measure defects in a number of ways, but that's likely going to be customer support requests. That's going to be returns and RMAs. It's going to be, quality related complaints from customers, right? That's one, reduce number of defects. Number two is improve the performance. And you're going to see this in customer satisfaction, star ratings, NPS, other kinds of maybe even reviews in review websites, right? And then number three is velocity. How often are you able to push updates? How often are you able to iterate? How fast are you able to iterate? So, improving quality, improving performance, and improving velocity are the three things that organizations typically will focus on. And you can see very specific KPIs for each of them.
Excellent. That's the end of the webinar. So I'd like to thank Francois Baldassari from Memfold very much for his great presentation and also for taking all those questions. I'd also like to thank the audience for attending and say that we look forward to welcoming you to another IoT Now webinar soon. Thanks again and goodbye from me.
Thank you, George. This was really a pleasure. And thank you for the thoughtful questions, everybody. I hope you have a wonderful rest of your day and that you'll come see us at memfold.com should you have any questions about observability or our solution. Bye now.